So these two pieces here, they interface together. This is an example of functional parts that are high strength prototypes. This material is similar to nylon, but these parts in particular have a secret feature that is not immediately obvious, but I'll show you on the printer later how it's done, and that's reinforcement with continuous carbon fiber layers. So these little stripes you see in here are actually layers of solid carbon fiber that are integrated into the print and reinforce the strength of the piece so that it approaches the strength of cast aluminum. So imagine what this would be out of a cast aluminum piece. This is similar strength to that. And that's how these pieces in particular were able to be installed on a boat and do the maiden voyage of the Gulfstream outrigger system from New Jersey down to Florida without breaking. It's because these pieces are structurally reinforced with carbon fiber filament. For these very special carbon fiber reinforced parts, we'll show you here on the printer how it lays a carbon fiber continuous fiber into the print. It's really cool. It actually creates space in the print that plastic normally would go, and then it lays out a carbon fiber layer. We have the ability with our software to design exactly where the layers go, how thick they are, how many they are, and we use that to tune the strength and cost of the piece. It's a really fun process for us. Another example of 3D printing being more advantageous than injection molding is when we're able to tune what is called infill. So on an injection molded part, they're solid on the inside, but on a 3D printed part, they can actually have what is called a pattern of infill on the inside. So some of the part is hollow, and there's a shape such as a hexagon or a triangle that allows the part to still be rigid, but not nearly as heavy or as expensive as it would be if it were solid. There are certain models of outrigger tips that we utilize this technology to be able to reduce the weight of the outrigger tip. This is really advantageous on outrigger tips because the tip of the outrigger is the worst place to add weight, and the tip is mostly cosmetic. So having a hollow infill part allows us to reduce weight in the most advantageous part, and it also reduces the production time. Here we've paused one of the prints in action so you can see what the inside of these look like. This is a tri-fill infill pattern. You can see the little triangles on the inside, but once the part is complete, you wouldn't know the difference if it wasn't solid on the outside because it has what we call wall layers that fully enclose the part and make it watertight. So here's an example of a part that is not 3D printed. This is an injection molded part by True Design. It's a 3-inch ball valve. But this, like the halyard lock, is an example of when we've used both 3D printing and injection molding together. So this is what it would look like here installed through the hull with the through hull and the valve on it together. And we thought a way that we can make this better would be to offer a reinforcement of the valve just to add a little extra security to the valve, supporting the through hull. So we developed this piece here. So this is our load bearing collar. This is a completely 3D printed part. We have a specialized industrial strength 3D printer that prints in this large size out of this strong material. This large print takes about 2.5 days to make one of these, but when it's finished, you'll see it's a very nice looking part. And this is an example of a test fixture that we actually put this on to a test fixture and load test this to failure, and in order to make sure that it passes ABYC requirements. Now, this is a part that the injection molding tool, due to the size and the shape, would be very expensive. It's also a part that is a very specialized part that there isn't a large demand for volume-wise. So it's a perfect example of when 3D printing makes sense. We can make this quickly without an expensive tool, and then it provides the amount that we need at a cost that's affordable. This is another great example of a piece that is for retail use that is 3D printed. This is our popular dredge boom meant for pulling heavy dredges, especially on center consoles. And this is an interesting story because we originally had a lot of these pieces were shaped like this one up top. This is what you'll see on our shade poles anytime you need to fix some sort of clip like this. But on the dredge boom, this is the heaviest duty version of this application. And initial testing revealed that this shape sometimes would bend. I don't think we had any actually break, but sometimes it would bend, and of course, that's not a good look. So we were able to redesign this part and create this version you see, which is reinforced. The success story of this being printed is that if we had opened an injection molding tool in this shape and then had to change it, we would have lost all of that investment of that tool, having to redesign it. With 3D printing, we're able to just change the model of the part and reprint it, and there's no lost cost because you didn't have to invest in a tool that would then be useless because it's obsolete. So this is a real fun success story here. I like this part a lot, and we're going to show a load test of this later to demonstrate just how strong this piece is. Here's our pull testing machine in action. This is a hydraulic machine that puts tension on the part As it pulls it apart, you'll see it here on the display. It shows how many pound force of load it's under. There are many parts that require some sort of certification, and this is a machine that we'll use to pull it apart to show that it does meet the standards. And a lot of times people are surprised. They think a 3D printed plastic part will be quite weak, and they're stunned to see how many pounds it does pull. So here it is. We'll show it going all the way to failure. Our failure mode here was on the outside edge. It broke at over 1,100 pounds. Considering we have a target strength of this about 200 pounds, this is a great example of a piece that really no reason to open up an injection molding tool. Suitably strong and UV stable, 3D printed, and we can make it right here in the shop overnight, put it right in the hands of the customer. This is really our bread and butter with product development. This is what we at Gemlux do that really no one else in the industry does as well as we do, which is taking parts that you can actually put onto a boat and use them, even if it's just for development processes or for a part that we intend to ultimately continue making with 3D printing.